Okay, continuing on today with our Laplace transform playlist. I'm just going to do another example with Laplace transforms using the unit step function. We have the Laplace transform of 2 minus t times the unit step function at 6. And before I get started, if you want to know more about the Laplace transform, you can go through this whole playlist. We start with an introduction and some other examples. So I'll provide a link in the description to the playlist, and also there'll be a link at the end of this video. And what we're going to do to start, we can use our formula down here to the right, which we derived a couple videos back. And this can make it real easy for us, because if we have a shifted function by the same c value on the unit step function, then it's real easy to calculate, because we just need to find the Laplace transform of the unshifted function. So getting to our problem, what we want here is we want this to be this piece, f of t minus c. Now our c value is going to be this, so our c is just going to be equal to 6. So we want this thing here to be f of t minus 6. And now we don't really see a t minus 6 in this problem. And in the next few videos, we're going to get into dealing with unshifted functions. But for this one, it's actually not too bad, because we just have a t, so it's pretty easy to manipulate. So what we'll do, we'll start with this. I'm going to call this my f of t minus 6. It's going to be just this 2 minus t, and we just need to manipulate it and create this. So what I'll do is, in for the t, I'm just going to plug in t minus 6. But then I don't want to change it, so I'll add 6. So that way I'm just adding 0. And then we'll just kind of distribute things out to make it really clear. So we'll separate this t minus 6 like this, and then distributing the minus in here, we'll have a minus 6. But then 2 minus 6, I can just write this as minus 4, and we'll have this like this. And now that we've created this t minus 6, we've got our shifted function. And now we're set up pretty well, and we have to find the Laplace transform of this, but we kind of have two parts here. And like I've mentioned in the previous videos, the properties of Laplace transforms are very similar to integrals. So like constant values we can factor out, and then we can split this on the minus sign. So let's see what we have. If I plug this back in here, what I'll do first is split this on this minus sign, so I can split this and write the first Laplace transform we want to find as minus 4 times the unit step function at 6. Then minus, for our second one, we're going to have just the Laplace transform of t minus 6 times our unit step function at 6. Now for the moment, let's just deal with the second one. So now we have this set up where our f of t minus 6, it's right there. So like our shifted function, f of t minus 6, is just going to be t minus 6. So then our unshifted function, f of t, is just going to be t. So in order to use this formula, this capital F of s, this is just going to be the Laplace transform of f of t. So that's just going to be this t. So we just need to find the Laplace transform of t, but we've done that in a previous video. This is actually going to be just 1 over s squared. So for all this stuff here, we can just use the formula, and we're going to have e minus c, which is 6. We're going to have minus 6s, and then we have our f of s here. So this is going to be 1 over s squared, or we'll just write it like e minus 6s, s squared. Okay, now for this second part, now we have minus 4 in front. We can actually just factor that out as a constant. I can write this as minus 4 times the Laplace transform of just the unit step function of t. Now in this case, it's a little weird using this formula, because we really don't have a function. Well, I can just kind of create a 1 here, and the shifting doesn't matter. So what we can do is we can just get, for this piece, the Laplace transform of 1, and that's just going to be 1 over s. So we can use that for our f of s value here. Actually, let me just move this so I can get some more space. So now that we have this is our big f of s value, and we have our c value, we can just go right to the formula here. So this is going to be minus 4. Then for this, we'll use this part. So this is going to be e minus 6s. This part's the same as this. And for our f of s value, this is just 1 over s, or I can write this all over s. And then let's just put these all together. So this piece is going to be, we need our minus sign, e minus 6s over s squared. And from here, we could just leave this as our solution. This isn't too bad, but I kind of like to factor it, because we have e to the minus 6s in common. So I'm just going to factor that out, and I'll factor a minus sign with it. So if I factor out minus e minus 6s, then from here, this is going to be 4 over s plus 1 over s squared. But then I can just get a common denominator, multiply by an s here. And so for my final solution, we'll have minus e minus 6s. This is going to, putting these together here, is going to give me 4s plus 1 over s squared, and that's it. So there you have it. We kind of just forced the shift to happen in this one. What I want to go over in the next video, we're going to look at the unshifted function. So what we want to find is a formula for the Laplace transform of just f of t, not shifted, times the unit step function. See you there in the next video. Thanks for watching. Have a good day.